What's hard about once we learn this lesson is the steps have similarities and differences, and once people have learned both, they mix them up, and it is a holy disaster, like I've said. So you have to study and remember the steps and the differences in the steps. Very, very important. Okay, so everyone, unlike multiplication and division, where you do not need a common denominator, with adding and subtracting fractions, you must have a common denominator. With these first two examples, they're super easy. I'm just making a point here, so just watching. So with adding and subtracting fractions, we would need a common denominator. So how could you make 3 and 2 the same? Multiply by what? 2 over 2, true? Yeah. You'd make it the denominator 6, because that would be the same. How do I make this a 6? Times by 3 over 3. The reason I'm doing that is because I'm adding and you need a common denominator. So your next step is to multiply out your numerator. So we have 4 over 6 plus, and then we multiply out our numerator, 15 over 6. Then guess what you do? You add the numerator only. So 4 plus 15 is 19, and that's all over the common denominator of 6. Then what we would do is factor and simplify. Everybody good with that? Okay, so then that's different though. When we have multiplication, guess what people do? They get common denominators. That is not how this works. So you have to remember the differences. You do not need a common denominator. We would multiply straight across. We would get 10 over 6, which would simplify to be 5/3, right, everyone? Okay. Here are the steps we need to take when adding and subtracting rational expressions. So they have similarities and differences, and you cannot confuse them. Take a picture. Factor the denominator only. How is that different than the last one? We factored all of it. This is really important to remember. We only factor the denominator when adding and subtracting. That's step 1. Then you also find the least common denominator. So look at my example. Notice I have just taken and factored the denominators only. Then let's find the least common denominator. Your denominator needs to look exactly the same, physically exactly the same. This one has an x plus 2, so does this. We're all good. This one has an x minus 2. This one needs an x minus 2. So we multiply by x minus 2 and x minus 2. Next important thing. If you have two terms, you always put parentheses. Now we're on to our second step. This is different. So on our second step, we actually do multiply out the numerator. Did we ever multiply stuff together in the last one? In the last example? No, we never actually multiply things together. In adding and subtracting, we do. We multiply out the numerator. We actually do have to multiply it out. Now we do that so that we can combine like terms. Now you can only combine like terms if you have stuff in standard form. So our second step is to multiply out the numerator and combine like terms. Then also not forgetting to distribute the negative. So what I recommend, just look, so right here, I would take, and my first step I would do is actually, with subtraction, I'm going to always change it to plus, right here, everyone watching? And then I'm going to make this, change the sign, and then change the sign. You only change it right there, though. Right, everyone? This isn't there. Pretend that's not there. Isn't that how we would change the sign, everyone? Okay, so now we would multiply out. Now notice, I'm ignoring the denominator in step 2 because we're not multiplying out the denominator. We're only doing the numerator. So I have an x plus 1. Nothing happened to the x plus 1. Then I have a plus sign. Then I have my negatives distributed, which I don't have them distributed right now, so I can distribute them and I get here. So I just multiplied out the numerator and combined like terms, and I ended up with this. Negative x cubed plus 5x plus 1. Now that's the numerator, and then that's still over the denominator. So I ignored the denominator for a minute, but now I'm on step 3. Once you combine like terms, you have your numerator divided by your denominator. And your last step is to simplify if possible. How do we simplify? Factor the top, factor the bottom, and restrict, then divide. Now isn't my bottom already going to be factored? Yes. Now my top, I would check and factor out whatever I can. So notice in this example I gave, I just factored out a negative 1. And then it's a cube, right? And it's not 2 cubes, and it's not quadratic, so we never learned a technique to factor this. So we're done. It doesn't factor, so it doesn't divide out, so that would be our answer. And then our restrictions would just be negative 2 and 2. I need to figure out why it's doing that. It's driving me nuts. It's like a delayed. Have you noticed that? Oh, it's the worst. Okay. Next thing, so let's start our example. So it says simplify. This first example is really easy. I don't think you need to take notes. So your first step is to factor out the denominator, not the numerator. Do not factor out the numerator. It's already factored out. Next step, get a common denominator. Already common. Next step, combine the numerator. Multiply out the numerator and combine it. Well, there's nothing to multiply out in the numerator, so combine like terms. X squared, any other x squareds? Minus 3x plus 7x. Plus 4x's, and then we have plus 6 plus negative 3. So that will be plus 3. And, yep. Well, if I would have had to multiply by x minus 2 and x minus 2, I need to distribute that stuff out.
Oh, I see.
Yeah. So now we'll combine like terms, which we've done, and then on bottom we have our x plus 3. You'd say that's my answer, but now does my answer simplify? How do we simplify? Factor the top, factor the bottom, divide out exact factors. So we do what multiplies to be 3 and adds up to be 4. 1 times 3, I can quick factor. The top quick factors to be x plus 1, x plus 3. Our denominator is x plus 3. We restrict before we divide. So x cannot equal negative 3. Divide out exact factors. There's our answer. X plus 1. Are we good? Moving on to the next example. Still an easy one. Do not write anything down for a second. I do want to point something out with subtraction. Some of you have a misconception on subtraction. I really need this group focusing because I know some of you are worried about your grades. So everyone, looking at subtraction here, there's a lot of misconceptions with subtraction. So look at an easy example. 6/5 minus 3/5. People say to me all the time, so I'm fixing your understanding. I need to take the negative and distribute it to the top and bottom. So that would be 6/5 minus 3 minus 5. Wouldn't that have been a plus sign then? Is this plus? No. Do you guys see how that is not a true statement? You don't distribute the negative to the top and bottom. Does everybody understand that? Okay, so where does the negative go? Well, it can go on top or it can go on bottom. It doesn't go on both. So this would be okay. 6/5 plus, put the negative on top. So I change the sign and put the negative on top. Negative 3/5. It is also okay to put it on bottom instead. So we could have crossed the line and then put it on bottom. Now don't I want a common denominator?
Yeah.
So wouldn't it have been better to put it on top?
Yeah.
Yeah, so I always, guys, always put the negative on top. Always. All understood?
Yeah.
Yes? Okay, awesome. So let's look at this next problem. You'd say, oh, it's a subtraction problem. I'm going to go ahead and make it an addition problem, and I'm going to take the negative and put it on top. So plus, right? Then this became negative, and this became negative. So now rewrite your problem. We have 3x minus 5 over x plus 1. Then we have a plus sign. Then now we have negative x minus 3, don't we? Over x plus 1. Okay, now we can start our first step. Factor the denominators, done. Second, get a common denominator, done. Third, combine the numerator. So 3x minus 1x. 2 x's. Negative 5 plus negative 3. And that's all over x plus 1. Now you'd say, that's my answer. I just have to simplify it if possible. Factor the top. Factor the bottom. Restrict. And divide. So we're done. Everybody good? Okay, let's go through the steps where we actually have to get a denominator. Okay, so looking at this one, I would write this one down. 3x over x minus 2 plus 2 over 2 minus x. Don't just say that these are the same thing. They're not. The denominator is not the same. We've got to rewrite this appropriately. So remember, the first step is to factor out the denominators only. So this denominator is good, so I rewrite it. 3x over x minus 2. Now plus, this denominator is not factored, and it's not even considered written the correct way. Let's rewrite it correctly. Isn't that negative x plus 2? Now, is that considered factored? No. What do we do if we have a negative in front? Pull it out, and then left would be x minus 2. True? So I have plus, and now on bottom I have negative 1 x minus 2, and then on top I have a 2. Now there's two ways to continue. Get a common denominator. So this one has an x minus 2 and x minus 2. Couldn't we get a negative 1 by times them by negative 1 and negative 1? Yes, that would be one way. Here's the second way. Isn't it okay to say, I'm going to take this negative and put it on top? We just talked about that. Bottom or top is okay, right? But not both. So I'm going to take the negative and put it up here. So now it's positive. Okay, now compare the denominators. Aren't they the same? Great. They are the same. So So let's go ahead and combine the numerator. Once we have a common denominator, the numerator is, we need to combine. So we have a 3x minus 2, and on bottom we have x minus 2. Restrict and divide. So nothing divided out. So we're done. So what if this would have been negative 2 on bottom? Let's pretend like I changed the problem negative 2. You could have taken the negative up, but then you couldn't take the 2 up. So what would I have to multiply here by? 2 over 2. Okay, good. Okay, next problem, write this one down. 3 over 8x squared plus 1 over 12x. Let's get a common denominator. You need your denominator to physically look the same. Now watch what I do. I take the smaller number. Since this only has one term, it's actually pretty straightforward. But watch what I do that makes my life easier. I take the smaller number, which is 8, and I figure out some factors of 8. Or not factors. What 8 multiplies, 8 times 1 is what? Can I make 12 and 8? No. Moving on then. 8 times 2 is 16. Can I make 12 16? No. Okay, moving on. 8 times 3 is 24. Can I make 12 24? Yeah, so that's the one we'll go with. So we need this to be 24, so we're going to times by 3 over 3. Now we need 12 to be 24, so we're going to multiply by 2 over 2. Okay, good. Now look at your denominators. 24 is good. This has 2 x's. This only has 1. So don't we need to multiply by x and x? Okay, so your next step is to multiply out the numerator. 3 times 3, 9. We have a plus sign, and then 1 times 2x. Combine like terms in the numerator. So 2x plus 9, right? And then the denominator, and this is the one time I would multiply out the denominator because there's not 2 terms. Because it is prettier to write 3 times 8 is 24. That is technically quote-unquote prettier. Does that make sense? If there was 2 terms, though, I wouldn't multiply it out. So 3 times 8 is 24, and then we have a x squared. So now we would simplify. Back to the top, done. Back to the bottom, done. Restrict, x cannot equal 0. Divide out exact factors. Can I divide the x's? Yeah. Yeah? Heck to the no. You can't divide across an addition sign. Right, people? Right, people? I wanted you to be like, heck no, Miss Christensen. Don't do it. Do you guys understand that you can't do that? Okay, moving on. Okay, now we'll get to some with some umph. I'm just making sure, though, don't write this one down. How would I start out? You'd say 10 times 1 is 10. Can 15 be 10? No. 10 times 2 is 20. Can 15 be 20? No. 10 times 3 is 30. Can 15 be 30? Yes. So you'd use 30. Okay, good. Okay, here we go. Write it down. X minus 1 over x plus 3 plus x over x plus 2. Your first step is to factor out your denominators. These are the steps you should be saying in your head every time. Notice I say them every time. You should be too when you get to the homework. You'd say, done. The denominators are factored. Now I need to get a common denominator. Okay, now guys, we can't get common denominators by addition. You can't say add 1, add 1. That doesn't work. You gotta get common denominators by multiplication only. So if this has an x plus 3, this needs an x plus 3. If you do that to the bottom, you've got to do it to the top, right? We're timesing the top and bottom by x plus 3. This one has an x plus 2. This one needs an x plus 2. Now, way important, if you have 2 terms, you need to use parentheses. Okay, what is your next step? Multiply out the numerator only. You're correct. So just ignore the denominator, people. X times x, x squared. X times negative 1 is negative x plus 2x. And then we have minus 2. Combine like terms. So we have x squared plus x minus 2. Then I cross it out. I've done that. Then I have a plus sign. Then I got to multiply out this. So I have a plus sign. X times x is x squared, isn't it? X times 3 is plus 3x. Notice I'm not writing any denominator. I'm just, while I multiply out the numerator, I don't write the denominator. So I have plus x squared plus 3x. Now we combine like terms. X squared and x squared is 2x squared. X plus 3x is plus 4x. True? Then we have minus 2. Now we can write that's all over the denominator of x plus 2 and x plus 3. You'd say that's my answer. Now I just need to see if it simplifies. So what we're going to do is factor the numerator, factor the denominator, and divide out exact factors only. So let's see if that quadratic factors. Oh, well, actually, let's pull out a greatest common factor. What would I pull out? Left is x squared plus 2x minus 1, and then that's all over x plus 2, x plus 3. Now you'd say, okay, what multiplies to be negative 1 and adds up to be 2? 1 times 1 Negative 1 and 1. No? Nothing. So we're done. Because nothing divides out and it doesn't factor. So x cannot equal negative 3 or negative 2, but that's our answer. Yeah. Okay, next one. Our first step is to factor out the denominator only. So we have, well, multiplies to be negative 8 and adds up to be 2. 6 times, not 6, I keep doing that. 8, 4 times 2, right? Negative 2. I can quick factor. So I have a final place where I put my final factors. X minus 1, and then I have x plus 4 times x minus 2, and then I'm going to go ahead and put in parentheses because that's required if there's two terms. Now it's a plus sign, so we're good with our distribution. We have our x minus 1, and then doesn't this factor to be x plus 4, x minus 4? Now we'd say, now we need to get a common denominator. X plus 4, x plus 4. X minus 4, nope, but I need one. And then this one would need an x minus 2. And then I need to put parentheses around that. Now, our next step is to multiply out the numerator. So watch, I'm going to do this in one step. X squared. Now I'm going to do this next one in one step. I'm going to add them in my head. I don't suggest you doing it. X times negative 1 is negative x. Negative 4 times x is negative 4x. That's going to add up to be negative 5x's. Negative 4 times negative 1 is plus 4. True? Then I have a plus sign. Now I'm going to do that same thing here. I don't recommend you doing it. X times x is x squared. Then I have a minus 2x minus 1x, which is minus 3x's, plus 2. Combine like terms. So we have 2x squareds, minus 8x, crossing them out, and then plus 6. And that's all over x minus 4, x plus 4, and x minus 2. And then we're simplifying, so yeah, we can restrict, but and especially because our denominator is already factored, but once again, factor the top, factor the bottom, divide out exact factors. So I'm going to pull out a 2 on top. Then left is x squared minus 4x plus 3. Now I got to check something. Well, multiplies to be 3 and adds up to be negative 4. 1 times 3, negative, negative. It does factor. So 2, x minus 1, x minus 3. Then I have my denominator still, x minus 4, x plus 4. And x minus 2. We restrict. X cannot equal 4, negative 4, or 2, and divide. Nothing? All right, then. Yeah, it's just, and so, but you see how if you forget the steps, then you start doing stuff and it gets messy. So you're right. If you remember the steps, like I said, Elise, this test, easy. Forget them, mix them up, do anything of the sort, and say goodbye to your test score. Just cry yourself to sleep. Yes. That's standard form. That's no better than factored form. So why do extra work? Does that make sense? Does that answer your question though? Okay. It's not that it would be worse. It would just be equal. So why do extra work? Okay. Okay. We get the picture. We get the picture with that one. I do want to do some subtraction ones. So let's just do at least one more subtraction one. This one maybe. And then I'll let you go. Okay, watch one last one. Because they're going to get big, some of them. So you say, okay, when adding fractions, I first need to factor the denominator. So I have 6 over x plus 3, x minus 3. Then I have a plus, x plus 1. If I see two terms, I put parentheses, x plus 3. Then I have a minus sign. Shouldn't I go like this? Plus, minus, plus. So I have a plus, and then I have negative x, and now it's plus 2. And then we have x minus 3. Does everyone see what I did? Now your next step is to get a common denominator. X plus 3, x minus 3. X plus 3, so we need an x minus 3. This one needs an x plus 3. Your next step is to multiply out numerator only. So 6, nothing happened to that. We have a plus sign. Now I'm going to distribute. X times x is x squared. Now I'm going to do it in my head again because I am really careful. Negative 3x plus 1x is negative 2x. 1 times negative 3 is negative 3. Then I have a plus sign, don't I? Negative x times x is negative x squared, is it not? Negative x times positive 3 is negative 3x, and then I have plus 2x, which is minus x. Positive 2 times positive 3 is plus 6. Now we'll combine like terms in the numerator. Didn't x squared go away in this one? Negative 2x minus 1x is negative 3x's. 6 minus 3 is 3. 3 plus 6 is 9. So we have plus 9, and that's all over x plus 3, x minus 3. Now you'd say, that's my answer, I just have to simplify it if possible. We factor the top, factor the bottom, divide out exact factors. Okay, good. Pull out a I was waiting for that. Pull out a negative 3, then left is x minus 3. On bottom we have x plus 3, x minus 3. X cannot equal negative 3 or 3, and bink. And so negative 3 over x plus 3. Okay, do we get the picture here? Do you guys see though what I'm saying though about the steps? Yeah. Please, I'm begging you to not mess up. Yes. Great question. Yes, before even going through your steps, I would distribute any subtraction signs. Yes. Okay, great. So finish 6.2, 7 through 70, odds or evens. Once again, don't be too confident in your abilities. Don't just do like 5 and go, shit, I'm so freaking smart, like I'm not going to do anymore. Like, if you feel at the point where you say, I'm good, you go find, this is what would be the true test. When you feel like I'm good, go find the hardest looking one possible, do that, and then if you get it right, then yeah, you're probably good.